Waiting for it to ding. There, it's dinged. Okay, so what we said for types of clouds, somebody said cumulonimbus. Those are your thunderstorms. It's the ones that you think of that are big and poofy on the top, and then they can be dark gray. If it's a big enough cloud, it's almost like it's nighttime. Somebody said nimbus. Somebody said stratus. There's different types of stratus. Stratus means like blanket. Altostratus is a mid-level blanket-looking cloud, yes. And then please wait to start this assignment. You'll have plenty of time to do this in class. And what I'm going to do at the end is I'm going to go back and let you know if some of you did not turn in the one from yesterday. And I know some of you were absent. But I'm going to, yes. That's going to be the last thing that I talk about. It'll be on there. Cloud formation. Cloud formation. We started talking about this yesterday. It's where we left off. I always like to end with starting to talk about the next thing in the next lesson. Principals love seeing that, so I try my best to do that way. And we left off with what was called condensation nuclei. So when you have what is called a parcel of air, a warm package, a parcel of air going up, because it's less dense, it's going to rise. Eventually, it's going to encounter lower pressure, and it's going to spread out. And then the particles are further apart, and it's going to start cooling off. It has to have something to condense on, or you're not going to have a cloud. And so your condensation nuclei, these itty bitty little things, for us, it's normally pollen. Okay, I looked up the California wildfires, and the most destruction that has ever been done in the past was about 2 million acres, and California now has had over 4 million acres burned. So a lot of the haze that we see, if the winds are just right, those are smoke and ash particles. And we normally associate ash more with volcanoes. We don't have any volcanoes around here. We have volcanoes in the country, they're just not any right here. How many geothermal, like hot springs and whatnot right here. I guess that's the last slide we're going to get to. Dust for us, because we're closer to Dallas and Fort Worth, we have a little bit more pollution in this area. That's why the lightning is so pretty in this area. How many of you have had the chance to see pink lightning before? What about green? You seen green lightning? Seen purple lightning? Most people think lightning is sort of that white, slightly off yellow color. Depending on what's present in the air, when it electrifies those chemicals from the pollution, it will change colors. And I have seen some very amazing electrical storms in this area for multiple reasons. Part of it is because we're at the tail end of Tornado Alley, where you have major differences in your low pressure, which is warm air, and your high pressure, which is cold air. And when those things crisscross paths, and the hot air rises and the cold air goes underneath, you have massive amounts of wind, and you have lots of friction, you have lots of buildup of electrical current, and you've got really big thunderstorms. Not all areas have the light shows that we have around here. We also, unfortunately, get a lot of hail because of that. Big hail because of that. That was where we left off yesterday. So here comes the sun, and the radiation goes into the water molecules, whether it's in a pond, the ocean, a creek. Maybe the plant is breathing, and in the process of breathing, it exhales water. It's part of this process. Well, the evaporation from the plant into the air is called transpiration, but it's still evaporation. We'll come back and talk about all of the different cycles eventually. But your air is heated by the sun, becomes less dense, expands, becomes less dense. And eventually when it gets up high enough, because of the lower pressure, it actually expands even more, but in this case it causes it to cool off. When you have colder air, your oxygen and your nitrogen lattice, and I should have done something like this yesterday, when it cools off, it shrinks. And when it shrinks, those holes become smaller. Boy, and it literally squeezes the water out of the air. When you squeeze the water out of the air, it causes what is called a microdroplet or a cloud droplet, and it's 0.02 millimeters in diameter. But that's still not going to happen if it doesn't have something to condense on, like I said, pollen, dust, smoke, ash, something in the air. Now, billions and billions and billions of microdroplets make a cloud. A water droplet, rain, is about 100 microdroplets put together, give or take. It's not a perfect number. But a microdroplet is 1/100th the size of a raindrop. A condensation nuclei is 1/100th the size of a microdroplet. So if you move the decimal 2 to the left, that's how tiny these suspended particles are that the water grabs onto and condenses on. Clouds are actually very, very heavy. They're just less dense than the air around them because the sun heats them up. So they float. The highest of the clouds that are in the upper layers of the troposphere, those aren't suspended water droplets, it's suspended ice. Those are the wispy ones. I don't have it, it's hard, I only have this teeny tiny window over here. I don't really see anything. It looks like a clear sky. It's normally a little bit hazier in the morning because the sun hasn't burnt all that stuff off. Let me check and see if I'm getting new people. It's just email. Probably telling me how many more of my students have been quarantined. I don't want to have one of those tests. Let's see, did we get somebody new? Christian Cooper, Erica, Matthew, Schuyler. No, is it my mail? Okay, I know all of these children are quarantined. Nobody in here. Couple chemistry and a couple earth space students. So it looks like since I last looked at it, 4 of them. Let me make sure I mark them on here. Mark that one. Mark that one. I so don't want to go remote 100%. I'm gonna cry. Okay, I got all of them. I can delete those. All right, y'all need a little bit more time. Are you ready? You have the next image on your Canvas document. It's in black and white on the paper because we can't, our copiers don't do color, not the mass copiers at least. And so you guys have this. I know it's a little cartoonish, but everything that's on here is adequate. And I really, if I wouldn't have been kicked out of my room during my off period, I would have added a couple vocab words in with the notes. But it's okay, it's on this image. So this is, technically this is transpiration because you don't see water that's being heated. It's heating the moisture from the plants, but it's still the same thing. So here we have the thermal radiation, the infrared from the sun, and it is heating up some source of water. In this case, it's coming out of the plants, which is called transpiration, but that's okay. It's still the same thing that's going on. So whether it heats up a pond or the ocean or just the moisture that's from the plants, it starts to heat up, and then you have what's called a parcel of air, sort of like a pocket of air that is less dense than the air around it because it's warmer. And it starts to rise, and once it gets high enough in our troposphere, it'll start to cool off, and it'll start to condense. Now, they don't make clouds until they go high enough. But as it rises, it gets colder and colder and colder until finally it hits the level of the troposphere where it starts forming a cloud, which is the beginning of clouds is normally about 5 kilometers in altitude above the surface of the earth. Those are the wispy ones. Those are the cirrus clouds, if anybody mentioned those. And then as those start to condense and they become heavier, they start to sink. And then they're coming in contact with warmer air. And so eventually they hit a part where they're suspended again. Somebody said the stratus or the altos, that's that level. Those can be light gray. And then as they condense more and more, they become heavier and then they sink down a little bit more until they're on the lower level. And those are your thunderclouds. Now, if you have a cumulonimbus cloud, the very, very, very tops can be very high up. Those look like the poofy cotton balls. But the very bottom normally looks flat. And they can be dark gray.
So what causes fog again?
I'll get to that in a second. And normally fog happens at night because the sun's not out and heated up. But I will get to that in just a second. There are three major things that control the formation of a cloud. Obviously, you need the moisture in the air, duh. But convection currents, which means that the warm air rises and the cold air sinks. Well, I know eventually they become cooler air. The condensation part, when you have enough moisture that the cloud is slightly more dense than the air around it, it will start to sink. But in general, and we're not talking about the other layers of the atmosphere, we're talking about the troposphere right now for like forever. Well, not for your test, because the other layers are on your test, but the part that we live in, the part has weather, and clouds, and rain, the part that we breathe, that's what we're going to be focusing on. If you have lifting, then you have warm air that comes up next to a mountain, and it has nowhere to go but up the face of the mountain. That's what California's problem is right now. Even though the ocean's right there, that moisture from the breeze, from the ocean, gets pushed to the Rocky Mountains. As that moisture climbs the Rocky Mountains, they start to form clouds, but it doesn't rain until they crest the mountains. So the plain side, the east side of the Rocky Mountains is the west side of the wet side of the mountain. The west side, where there's a desert on the other side of those mountains, is the dry side, and California cannot get a break. They can't get any rain. And they are on fire. Literally on fire.
It's their own fault.
Well, part of it is the fact that they don't clear their underbrush, but I mean,
They don't clear their underbrush, they're throwing people on the pollution. It makes everything worse. I mean.
I don't think I could live, maybe upstate.
I would not live in LA.
Oh, no, I couldn't live in LA. No. But upstate, I know I've got like removed cousins that are up towards wine country, which is also on fire. But upstate California is actually really pretty. It's nice. But no, like LA and San Francisco, San Diego's supposed to be very nice.
I mean, it's all nice because it's California. But the air quality.
Yeah, the air quality is not good because part of it can't go up that mountain and it's stuck there in that valley. And if you ever fly over the mountains, like if you're going to LAX, it's like beautiful. The air is so clear that you go over the mountains and it's just small. It's just disgusting.
Yeah.
Fronts, like I said, we may be picking up, you test on Friday, we may be picking up this weather this year. I said, I don't know, I haven't gotten that far. You have low pressure, which is less dense, which is warmer air. Comes in contact with high pressure, which is more dense, which is colder air, and the warm air goes on top of the cold air. And where they interact, where they rub against each other, you have friction that causes the buildup of static electricity. And then eventually you have enough where it has to discharge and you have lightning. The bigger the temperature difference between the warm and the cold front, the more wicked the weather is. Y'all still need this one?
Yeah.
Well, I see somebody ready. Wait,
I'm writing something.
you're writing something else.
Yeah, I'm writing names if I know the answer.
All right, next little bit. Why clouds look white? Now, it depends on where the cloud is. It depends on the density of the cloud. White clouds are normally upper level clouds. The sunlight can, now it scatters as it goes from the top of the cloud through the bottom, but it can penetrate through the cloud. It heats the cloud, it warms it up, keeps it in higher elevation because the heat from the sun, from the insulation from the sun, makes it less dense. The very high clouds are made of ice, suspended ice. If the sun can go through it and it scatters, you're still seeing all the colors of the sunlight, which was white light. Now, if that cloud sinks and becomes more dense, then not as much light can go through. And when you see gray on the bottom of a cloud, or a really bad storm looks black on the bottom, you're seeing the shadow on the underside of that cloud. The light cannot get all the way through. Now, sunrises and sunsets are different, and they look pink and purple and red and orange and all that stuff. That's different. But why it looks like thunderstorms have got a gray, or even, like I said, if it's a bad enough storm, it almost looks like it's nighttime. The light can't get through it. You're seeing a shadow on the bottom of the cloud. The cloud itself is really not gray or black. It just has to do with how much light can get through it. Just like the sky is not really blue. The sky is clear. Not that bluish purple color that we see. That's what our eyes pick up, but it's really clear. We just see that specific wavelength because that's the angle of refraction from Snell's law that reaches our eyeballs down here. Which is also why sunrises and sunsets are different colors, because the angle of refraction is different and we see a different part of the visible spectrum. Yeah, but look, this one's pretty short. Or does anybody still get it?
What do you need to?
You guys need to put a mask. Why are you trying to breathe cues on me? We're 20 feet apart. You two aren't 20 feet apart. Well, they were until they had to add the extra row, and now I have even more children who are showing up in the chemistry class. I don't have any students.
How many put them in the back?
I have 27 in that class. Huh? I think so. Most of my classes have 23, 24. I counted out the squares before I had to add the extra row. So I just mentioned that clouds float, sun heats them up. The warmer air expands more than the air around it, and it's less dense, and therefore clouds float. Clouds are very heavy. They're just less dense than the air around them. And the process that they heat up is called solar insolation. The heating from the sun, because the name of our star is Sol. And as long as that cloud is warmer than its surrounding air, it will stay up. As soon as it starts to become a little bit more dense, it will start to sink. And then you have your mid-level clouds. They condense more, and once they're more dense than the air around them, then they sink again to your low-level clouds, which are the ones that give us rain. Yep, fog would probably be the question. What about fog? Fog happens at night, normally around bodies of water. Well, boys, question about fog. At night, the sun is not out to heat up the cloud, and it will sink due to its own collection of moisture. And it rests on the ground, particularly around bodies of water. And then not until the sun comes out and it starts heating that fog back up is it going to start to rise and then eventually dissipate and go back to being a proper cloud up in the sky. I don't know if you guys get really bad fog here. It's been so long since I lived up here, but if you visit more towards the coast, Port Louisiana is about to get hit by another hurricane. You're out like, because they have bayous. They don't call it creeks, rivers, they're called bayous. Huh? That was Gamma. This one's Delta. This one's going to hit the same area of Lake Charles and then over towards New Orleans, unfortunately, they're getting hit again. And last night when I looked, they were projecting a category 2. This morning when I looked, they said maybe a category 4. Yo, Lake Charles doesn't even have electricity back yet because they were flattened, completely and totally destroyed. I feel very sorry for them. So yes, fog, low level cloud, eventually the sun comes out, heats it up, and it puts itself back up in the sky like it's supposed to. There's been a few times where I moved from, because we had such thick fog banks, that you could walk and your head would be in the fog. And if you just sort of did this and ducked down, you could see clearly right underneath it because it was in the process of lifting. So extremely dense fog where where you can't drive, kind of dense fog. Where the animals don't even make noises in the morning because it's so dense. Ready? Moving on, clouds move by wind power. They can't steer themselves. The fastest of the clouds are the ones that are the highest up because they are the least dense. Over 100 miles per hour in some cases. Your slower moving clouds are your thunderclouds, the ones that are lower down and are the most dense. Most storms, now there are some exceptions to the rule. Most thunderstorms don't go past 30 to 40 miles an hour. Hurricanes are exceptions, because we have another one that's brewing yet again. That has to do with the fact that you've got massive differences between your high and your low temperatures. And the greater the difference in the temperature between the warm and the cold front, the more nasty the storm is. Now, we do get some thunderstorms that race across the plain states that go a little faster than this, but this is normally the maximum for a regular old thunderstorm. Now, let me put it into a way you can understand it a little bit better. You have a red light, and at the red light, you got a motorcycle and an 18-wheeler. Who is going to accelerate faster?
Depends.
Okay, a loaded down 18-wheeler and a motorcycle. The motorcycle is going to take off faster because it has less mass. The cirrus clouds are the lightest of the clouds, therefore they are going to move fastest through the sky. Yes, what's the question? Yes.
So the highest clouds are going to move fast.
Because they are the less dense.
Yeah.
Thank you.
Besides, it's also windier in the upper layers of the troposphere anyways.
That's true. Where the planes fly at? 30,000 feet.
Planes are around 35,000 feet, give or take. Yes,
You're above the clouds.
you are above the clouds, you are not quite into the stratosphere yet.
Well, I've been in the clouds and I've been above the clouds sometimes.
Now, if you're flying through clouds and you're at your cruising altitude, well, no, there aren't any clouds at cruising altitude. On your way up, the last clouds that you go through, those are going to be your cirrus clouds. The ones that cause the most turbulence are your lower clouds, your denser clouds. And it's the wings that are coming in contact with the moisture that's more dense that causes that vibration. There are other things that cause turbulence. Huh? Most people, if they don't like flying, it's because of turbulence. I personally don't like the taking off part because I know full well if that plane doesn't make it off the runway, we're going to burn to death.
What?
Because its belly's full of fuel. If that plane starts going down and I'm up at cruising altitude, at least I'm going to die on impact. But I don't like the taking off part at all. Besides, that's your better chance to strike a bird. The bird's going to the engines. You've never paid attention on commercial flights. If you look on at the engine, the part that spit like inside the fuselage, there's an offset dot. Do you know why they do that? And it's to make the birds think that it's something alive that's coming after them, so they'll get out of the dang way. Problem is the plane's flying a lot faster in relationship to how quickly the bird can maneuver, and so you still have plane strike.
So you stop it, jet, and
If it goes, it gets sucked up inside the engine. People have been sucked up inside the engines, huh?
You just get shredded.
Yeah, it does, but it can still damage the engine and cause it to fail. It happened to Pence's plane not too long ago. They had to land, and then he had to take a cargo ship. Like a week ago, there was a bird that got sucked into the engine. Pence was getting ready to go, and they had just gotten off. And I don't know what it was, a seagull or something. Got sucked into the fuselage, and they had to land and get on a cargo plane to bring him back. I forget where he was. Literally, it was just a few days ago.
How does it land on the No.
Like an air.
They landed on the airstrip.
They landed on the airstrip and they got out of that and went on to a cargo flight, cargo ship, cargo plane, thank you. Not like a boat, like one that delivers mail and that kind of stuff. Freight, cargo. Clouds, they're gonna put into categories about how high off the ground they are. We call that altitude. Remember, if you climb up the mountain, that's elevation. If you're suspended in the air, that is altitude. There. I guess if you flung yourself off the mountain,
Yeah.
as you were falling, that would be an altitude.
Yeah.
I don't suggest you go fling yourself off the mountain.
Yeah, I'm understanding.
Okay. I guess technically you're right. While you're falling, you're decreasing your altitude. They're really inventive with their naming of their classifications. So the ones that are the highest up are called high level clouds. The ones that are down below that are called mid level clouds, and then the lowest of them all are called low level clouds. There are some that are miscellaneous. We'll come back and talk about those when we do weather. Different things, sort of in between. Doesn't quite fit 100% in one of the other categories. Now we're going to take a look at what the specific altitudes are for these, which are the next couple slides. We'll talk about the type of cloud that likes to throw out tornadoes at people. And we're going to end just by looking at the water cycle. I'm not going to ask you questions on the assignment about the water cycle, but that's the one that we've been talking about. Okay, so high level, they're at least 5 kilometers up, at least. They are the wispy ones. We call those cirrus clouds. If cirrus is in the prefix, it's a wispy cloud. It's the highest of the clouds. They are made up of suspended ice particles. Cirrocumulus. Cumulus means fluffy like a cotton ball. Stratus means flattened out like a blanket. But if it's a cirrostratus, it's still way up in altitude. If it's an altostratus, then it's the next one down. That's a mid-level. They like to give these the prefix alto. Altocumulus is going to be a fluffy mid-level cloud. An altostratus is going to be a flat blanket-like cloud.
Yeah, so that's the problem. It's very flat.
Yes, they're the flat ones. It's sort of like a blanket. Cumulus are the ones that with a bunch of cotton balls put together. They're fluffy. That's the ones that people go cloud gazing. If they still do that, they look to see what the cloud looks like. Does it look like a dog, or is it, you know? I people still do that anymore. You don't think so? Mid-levels, somewhere between 2 and 5 kilometers. Yes, there is a little bit of overlap on both sides, but in general, that's where your alto clouds are. There are way more than this. These are just a couple examples of each particular range. And then the next one we're going to do are low-level clouds, which I have to put on a different slide because I couldn't fit it on here. Oh, we are really good. We got 25 minutes. All right, now the next one, your low-level clouds. These normally get some, either a prefix or the root word, some type of a cumulus notation. Stratocumulus is going to be a lower level blanket type. Stratus is also in this particular zone. These are going to be below 2 kilometers down towards the ground. Give or take. And then the other answer, somebody asked, what was the answer to that question? Anvil clouds. Anvil clouds are the ones that like to throw out tornadoes. If you've seen like Roadrunner and Coyote, an anvil that's constantly dropped on his head, that's this upper part. They're going to always have a very flat bottom, and they're going to have almost what looks like an upside down bell. This is the anvil. You've never seen, like, you've been to like Scarborough Fair or the Renaissance Festival or whatever it's called up here, the people that make metal things with the hammer and the anvil, the thing that they're striking on is the anvil. It's got a flat surface. And that is why this thing is called an anvil cloud, is because it looks similar to a blacksmith's anvil. If you see these, You don't need to be staying outside for a long time, especially if they start changing colors and they start turning the sickly shade of greenish yellow.
I've seen one above my apartment and just spinning around.
Yeah, either the circular rotation, yeah, that's even worse.
They never touch. They never
Well, they're trying to make a tornado.
yeah. It was pretty scary.
Well, and if you've ever been through a tornado, the sound that they make is almost, it whistles, it whistles, but it's almost like a train going past you. If you've ever seen the original Jurassic Park, the T-Rex's scream, they actually used recorded tornado audio in order to make the bulk of what voice was that they gave, I guess voice, scream, screech, whatever, roar. I don't know what the heck the term is for what a dinosaur makes sound of. That's where they got a lot of the info to be able to do that audio for that dinosaur. But these are associated with tornadoes and unfortunately very large hail. And this area gets some decent hail.
Oh, no.
And then you've got the people that are the storm chasers that purposely go out and try to find these things. Well, except for if you get killed, because they do get killed by them. I mean, I've seen tornadoes, I've been through hurricanes, I would not actively want to seek one out. And honestly, I'd rather deal with a hurricane than a tornado, because at least you have warning. At least you can get away. The tornadoes, they're on you before. I mean, I know there's a siren here. Because when I first moved in, I was doing yard work and I heard the sirens go off and I was like, there are any clouds in the sky? I didn't know that they tested the sirens to make sure that they were working right.
Yep.
I'm not used to tornado sirens. I am used to hurricanes. And there's no such thing as a hurricane siren. It's, hey, it's coming for you. You need to evacuate. And if you choose to stay, then just be prepared to not have electricity or water for a while. Or you're going to have to be, for us, a lot of people were taken out by the Cajun Navy. All right, now last little bit, you have this. Yes, I know it's cartoony, but it shows what we've been talking about. The part that we have focused on when we're talking about the atmosphere is part of the water cycle. So you have the water that is heated by the sun, which is not in this picture. You have natural evaporation, which condenses in the clouds. Eventually, your cloud becomes heavy enough as it sinks from layer to layer. And then eventually, you can't hold that water back anymore. It has some type of precipitation, which is normally rain. Now, we haven't talked about aquifers and groundwater and runoff and all of that. We would get to that, how water's naturally filtered as it goes from one place to another. But we have talked about this particular portion of the water cycle already. We will come back and do cycles later on. And let me double check online. I need to double check and start yelling at people for not doing work. Not really yelling, just let you know you're about to get parent contact. If you're not turning in stuff and you're failing, that's what I meant to do during my off period today, but my room was sanitized. So I couldn't do anything in here because I was in the competition gym. All right, now let's check online. I don't see anybody new. And let me check your grades. You're not in chemistry. You're in earth space. Y'all have more than enough time. We have 20 minutes for you to be able to do that assignment. Oh, come on, computer. You can do it. Okay, so the opener from yesterday. I know you were not here. Okay, but Avery, I didn't get one from you or the assignment because you weren't here. Matthew, if you're online, I didn't get either of those from you. Christian online. Yes, Christian online. I didn't get the opener, but I got the assignment done. This was from yesterday. It's still open. Colton, if you're online, I didn't get both. Haley's not in here. Oh, I just got Ashton's opener, so let me put that on here. And then Skylar, if you're online. Skylar, you've been absent, I think. 'Cause I'm not seeing stuff, but I didn't get yours from yesterday. Let me look at my attendance book. You've been absent, Skylar, so I'm going to have to. You're still online, right? Let me see. Yes, Skylar, you're still online. So I'm about to go back and I'm going to open them because they're closed. So I need to, oops. Ungraded. 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 Okay. More space. Give me a second, Skylar, and I will open them back up for you. Edit. People. All right, Skylar, I'm giving you, let's see, you were out 4 days. 1, 2, 3, that would be the 4th day. I will give you till Saturday. Were you here yesterday? You were here yesterday. Now I'll give you till Friday at midnight. That way I can get my grades taken care of. Oh man, I just did this the wrong way. All right, let's. Okay. Add. All right, I am opening them up for you, Skylar. I'm opening up the openers. I'll open up the assignments in just a minute. Oh, okay, there's the opener from last week. There's the, you can access the YouTube to still get the notes. Add. My keyboard is not behaving. Oh gosh, darn it. Okay, I got the 29th opener. They're in your notes. You all look back at your stuff. Okay, so 9/29 opener. You know, I should probably stop recording. All right, just give me a few minutes, Skylar, and I will open all of these back up for you. It just takes a few minutes for each one to happen. Stop recording. Okay, there's the opener. Here's last Tuesday's assignment. Come on. No, I really hate Canvas sometimes. For the one that was absent, yeah, she was gone for like a solid week though. Oh, dang it.
No, there's like.
Okay, and then here is the. All right, Skylar, the 28th and 29th openers in assignments. I'm doing the 30th. Oh, gosh, edit. Button. Where are your notes? But why is it his responsibility to?
My handwriting says this is pretty good.
Because they're friends, that's all.
Uh-huh.
That's the job of the thing.
Well, he's like, you
Not again,
Okay, the 30th is open back up.
notebook
First, I'm opening
know.
up. Bless you. Okay. Right, I'm opening the first now for you. Right. And then Friday. Friday didn't have an opener, it had an assignment though. It's all right, everything from last week when you were not here is now open, Skylar, and then the one from yesterday is still open for now. That should have taken care of you. Okay, now the rest of us, most everything else has been locked, unless if you've had a bunch of absences. And if you weren't here yesterday, the couple of you that were not here yesterday, it's still open, the stuff that we did yesterday. You got like everything done except, hold on, I'm looking at you right now. So yeah, I've got 28th done, I've got all the openers so far done, I got the 29th done, 30th done. Huh? That was the assignment. In your case, you have to do it.
No, like, there's no way, because they don't even have safe one.
They're bad anyway, and then they don't even have their best player.
They're gonna beat the Giants, and all my years we're going to the Super Bowl.
Yeah.
That's
I'm just saying.
The next rest of the season.
I'm just gonna have,
The Cowboys are not going to.
No.
Okay, and then,
No, they won't even make it. They might get first.
okay, so,
And then maybe the playoffs, he's gonna get smacked in.
I called everybody else out. I'm gonna mute myself.